Welcome to the unofficial closing ceremonies to Black Hat 2017. Glad you guys could make it. It's awesome. We're going to talk today about Revoke Obfuscation, really the depths of how crazy PowerShell obfuscation can get, but also some crazy math and science that we can do to give you a fighting chance as defenders. But is AV still here? We were told that we were going to get the laser show like that Jeff Moss got. Whatever, we'll go on. So I'm Lee Holmes. I'm an architect for Azure Management. I'm the author of the Windows PowerShell Cookbook and was a developer on PowerShell since the first version.
And my name is Daniel Bohannon, and I am a senior applied security researcher for Mandiant. Prior to that, doing some IR for Mandiant. I'm the author of the Invoke Obfuscation and Invoke Cradlecrafter PowerShell obfuscation frameworks. Yeah, just really excited to be here talking about this with you.
Now, so to get things going, what we're going to first talk about is basically a treatise on blue team follies. So if you take a look at the way that people are trying to detect malicious, underhanded, any sort of PowerShell out there, we do see a bunch of things that make it difficult, but also where people are making mistakes that are very, very easy to bypass. So some background and some context. We're going to assume here that there's really a couple prerequisites when it comes to doing any sort of detection of PowerShell. One is that you've got command line logging enabled, so event ID 4688. You can get this from that, or you can also get it from deploying Sysmon, a really great tool. But also, when it comes to the PowerShell specific stuff, PowerShell in version 5 has really, really changed the game when it comes to what it means to be a transparent scripting engine. So the two things here are the PowerShell script block logging and module logging that really, really make a big difference. Attackers aren't in the habit of enabling these logs for you, so you might want to do it before you encounter them. So this is the typical way that people start to try to do any sort of analysis of PowerShell obfuscation or detection of malice. Usually it starts with the event log logging from the process command lines. So this is what somebody might do. Anytime I see PowerShell with a given command line, I'm going to use that as my flag to detect when something malicious has happened. However, PowerShell, like most languages and automation engines out there, doesn't need to take all of its stuff from the command line itself. You can also pass input into PowerShell standard input. So if you're doing PowerShell obfuscation or malicious detection based on the content of PowerShell command lines, here's two examples that you're not going to see anything that might have happened itself. So this is somebody taking CMD, piping content into PowerShell through standard input, and it runs. You can see here it runs successfully. This is what it looks like in the command line logs. Just PowerShell dash or PowerShell invoke expression input. That's not going to get you anywhere. However, that might be a bypass, but when you're doing it this way, you will see CMD that called PowerShell. You will see the commands that were actually used to pack all of this stuff into PowerShell and run it. So maybe that's kind of your approach. You don't want to detect just the PowerShell command lines, but maybe you start looking at CMD calling PowerShell itself. So here's the question. Can we start to just key off of CMD calling PowerShell? Maybe that's a bad thing to do. But unfortunately not. Here's an example where CMD can run any command that you give it based on information that's packed in environment variables. So here's an example of packing some information in an environment variable, and that represents calling PowerShell itself. So this is now CMD echoing into the thing represented by an environment variable and running it. This actually happens in the wild. This is an example from Fin8, some malware. They're financially motivated attackers. This is what their malware looks like. Rings a bell, doesn't it? This is exactly what we were just talking about. This is what they're doing. Another point, too, is it doesn't just have to come from standard input. You can pack the information in environment variable itself and have PowerShell run the content of that environment variable. Kovter is a malware strain that does this and loves it as well. Environment variables are one, but what about the clipboard? There's tons of different ways to start sending content from PowerShell from another process. So you might say here, here's a clipboard, an example of that. You might say here, let's start doing detection anytime CMD is calling PowerShell. Maybe we even start to do this among a process tree, checking a couple different ones. So here's kind of the demo that we were talking about before. But what I can also do is I can do CMD to set some environment variables, pipe that into CMD to process the environment variables, and then pipe that into PowerShell. So if you had any detection going on directly, arguments in CMD to arguments in PowerShell, that's going to be broken as well. Now here's a problem. It seems like it works, but you look at your command line logs, and ultimately the parent process, you see it anyway, so maybe you're not so bad off. This little shield mark that we have here, that represents some of the stuff that's still going to show up in the actual PowerShell logs. So if you've enabled PowerShell v5, the script block logging and module logging, you're still going to have evidence of this happening as well. However, take a look at that pipeline. What happened is that first CMD took your whole arguments and ran it, and so what I can do is escape this command line. That works. You got an example here of CMD echoing something that you can't even tell, and then running PowerShell. So maybe you start to say, do I look at the whole tree from win init all the way down to PowerShell? Maybe that's your approach, is to really start combining these things. But you've got some problems. There's a lot of ways to launch PowerShell, and then another window where there is no shared parent process. What if you launch a PowerShell with a specific window title, and then launch another PowerShell as a sibling that reads from that window title? What about reading from files, registry keys, anything like that? You cannot depend on a parent process tree either. There's so many ways around it. So the good news, as I was mentioning, is that PowerShell script block logging captures all of the stuff that actually makes it into PowerShell, but you still got a problem. We didn't even talk about at all yet any of the content in PowerShell itself.
Yeah, so let's shift over and look at that. So Lee just covered a lot of examples and kind of showing the folly of, as a defender, why we shouldn't just look at PowerShell.exe's arguments or even its parent process arguments or even recursively. But again, PowerShell logging in PowerShell 5 will have all of this information, and script block logs really are your best friend, the EID 4104. So what we're going to do at this point is we're actually going to look at obfuscation techniques that exist that actually never get deobfuscated in those logs. So whether you're looking at command line analysis or actual script log analysis, you need to be aware of these techniques and how they could affect you as a defender. So at the very top here we have an example command, and this is the most common plain Jane remote download cradle. What I mean by that is this command will basically read from this remote source. It'll download this script into memory and then pass it to invoke expression or IEX, which is kind of like PowerShell's eval statement. And so this will all be executed within memory. And we see attackers using this all the time. And the reason is that copy and paste is every developer and hacker's best friend, and you see this in popular frameworks like Veil, PowerSploit, Metasploit, all over the place. And so let's walk through this example. We have this attacker command up here with a totally legit bit.ly link. Feel free to run that if you please. And then as a defender, how could we catch this? And let's think about the command line example here. It'd be the exact same for script block logs, but let's say if as a defender we look for arguments where we see invoke expression, new object, system.net.webclient, and download string HTTP, this would catch this exact command. So now, let's walk through and have a little fun. So first off, system.net.webclient. Pretty much anytime you see system. In PowerShell, it's referencing a .NET class, and you don't actually need system. PowerShell will go ahead and handle that for you. So if an attacker doesn't have to have that, then as a defender, we don't want to make that assumption that we also have to have that in our defenses. So as we change our attacker command at the top, we're also going to change our defender commands underneath. Next, the URL is a string. And so with a string, we can just concatenate it in line just like that. We're also not limited to any kind of quotes. We can use single quotes, double quotes, put white space in there. A lot of options there. So let's go ahead and remove that HTTP and the quote from download string. All right, download string. Now, if you look at this command, PowerShell interprets this in what are called tokens, hence why we call this token layer obfuscation. So for example, the URL, that's a string token. Download string is a member token. And so given any member token, what are ways that we can really screw around with it to make the syntax look really odd, but it still work? So if you'll notice with download string, before we even apply any kind of syntax obfuscation, download string is just a method to the net.webClient class. But there's a lot of methods. In fact, here's just a partial list here. So the main ones I would say to definitely keep in mind are download string, download file, and download data. Download file will download to disk. Download data will return a byte array. So maybe we can just cover all of these by saying instead of looking for .download string, let's just look for .download. All right, so now that we have that done, with a member token, what we can actually do is we can also set that value into a variable. Or we can set the object instantiation in a variable. So we can't even rely on that parenthesis being there. So let's go ahead and pull that out of our Defender triggers. So now, how can we obfuscate this member even further? We can actually put single tick marks around it. We can put double quotes around it. Now the fascinating thing is that when you put double quotes around it, and I want you to look closely at download string, what you can actually do is just put a tick mark there. Now, why in the world does this work? Well, this works because the tick mark is PowerShell's escape character, or called the grave accent character. So I like to think of it kind of as a grave of a lot of Defender's IOCs, because this will break a lot of stuff if you're not aware of it. The tick mark before these 8 characters will do things like tick 0 is a null, tick n is new line. But if you have a tick mark before a character that has no escapable meaning, then PowerShell processes it and there's nothing else for it to do with the tick. So you can actually put tick marks in front of any character that's not one of these 8 here. And in fact, if you're like me and are just really, really dying to put a tick mark in front of those characters, all you have to do is just uppercase the characters, and then you can put a tick mark in front of it. So now, we have tick marks in front of any character that we want, except for 0. Unfortunately, there's not an uppercase 0 that I'm aware of. But we have a lot of options here as an attacker to mess with this. Now, here's why this is really, really important. On the top, you'll see this is what it looks like in command line event logs. Or if you have some kind of real-time agent, this is exactly what you'll see on the command line. Those tick marks are still there. And at the bottom is PowerShell script block logs, and the ticks are still there. And the concatenation is still there. So everything we're doing right here still persists into those script block logs. All right, so maybe we can come up with some crazy regex to take into account these tick marks. Sure, I guess you could try that. If you wanted to go down that route, don't just stop at download, because in addition to download string, file, and data, there's also open read, which will return a byte stream. And we have seen attackers use that before. So again, it's really important as defenders that we know what's possible and that we know the flexibility of PowerShell, and any language for that matter, so we're not making bad assumptions on the defenses that we're putting in place. Another thing, if we encapsulate the member token inside of parentheses, we can actually then treat it as a full-blown string. So we can concatenate it, we can set it in variables, we can do a lot of crazy stuff. And if you'll notice this .invoke after those parentheses, that's only required in PowerShell 2. PowerShell 3 and later doesn't even need that. So make sure you're not basing your defenses on that .invoke, because it's totally not necessary in later versions. So if it's all right with you, I'm just going to go ahead and remove that one. That seems like some crazy regex to do. We already have other stuff in here that we can count on not being obfuscated. Is that cool? All right, let's keep going. So net.webClient. This is the name of a .NET class, but in the context of this PowerShell command, it's actually an argument token. It's an argument to new object. So argument tokens, really easy to obfuscate. We can use double quotes and tick marks. We can put it in parentheses and treat it like a string. We can also chunk it up into variables and then just put those variables together in the command. So we'll just go with the first option there and remove that from our list of Defender terms there. New object. So if anyone here has used PowerShell, I actually kind of accidentally happened into PowerShell. I was writing bat files and someone said, why don't you change that to a .bat to a .ps1 and like almost all your stuff is going to work. And I said, really? What's the point? He said, oh, it's so much more powerful. And so yeah, it's like my bat file had dir, had del, all this kind of stuff, and it totally worked. PowerShell is really inviting to newcomers to pick it up, because if you want to, let's say, enumerate all the files in a directory, if you come from Windows background, dir works. Linux background, ls works. The formal commandlet in PowerShell is get child item. You can also just do gci. So PowerShell has tons of what are called aliases to give you lots of options to make it really, really user-friendly, and it absolutely is. However, as a defender, that means you have to be aware of all those options. So you want to make sure you're not writing triggers on things that have a lot of other ways you can write it. The good news is that with new object, there are no aliases. So at first when I saw this, I thought, awesome, this will be a really good indicator. However, PowerShell is really helpful. It goes out of its way to be really helpful. So for example, if there's a commandlet that I know I've used this commandlet before, but I can't remember what it is. It's new-p something. Then we can just say git command to list all the commands and functions that are available. So if we say git command new-p asterisk, then it'll list all the commandlets that match that. So what we can do then is if we return just a single commandlet, it's actually displaying PowerShell objects, but if we return that single commandlet and pass it into invoke expression, behind the scenes it'll automatically transform that object to a string, which is the commandlet name, and then invoke it. So this is just like calling a new object. However, we can get a bit more creative with this since we're dealing with PowerShell objects. Instead of invoke expression, what we can actually do is use the dot or the ampersand. Now, these are invocation operators. And also, if you'll keep in mind, remember when we were trying to figure out that new-p commandlet, we can use wildcards to search for the available options in the argument. So this is a new object. And then that's also a new object, as is that and that. And there are as many combinations as you can dream of to return just new object. So now if you're looking for new object on the command line, you'll never see it. However, where you will see it is in PowerShell module logs, which is EID 4103. Now the thing to keep in mind is that if you have a massive script, every single commandlet and every parameter binding will have its own module log. So basically there's a lot of them. So all the evidence is there. It's just in a lot of different places, which makes it challenging as a defender to piece it all back together. In addition, git command also has an alias, of course, of GCM. And it actually has a very interesting alias that really bugged me for a long time because it's actually undocumented. Is it okay if I share that with you? It's kind of top secret. It is command. Now this works because PowerShell, again, it's so friendly. It's like the best friend you could ever ask for. Whenever you type command, it'll say, I don't see a commandlet or a function name command. Maybe you forgot to type that git dash. Let me go out of my way and see, yep, there's a git dash command. Like, here you go. So now, anytime you've written an indicator on any commandlet that starts with git dash, you don't need that git dash. It'll automatically work. So more options to keep in mind. In addition, if we don't ever want to use a wildcard for this new object stuff, we could just concatenate new object into some other variables and then call git command on that. There's yet more options. PowerShell 1.0. If you if you're on the blue team or the red team dealing with PowerShell, poshcode.org is an amazing resource because there's just a lot of new and really old scripts there, and there's a lot of PowerShell 1.0 syntax that you can find, which a lot of people aren't aware of. And there's some crazy stuff that you can do that is a lot shorter and easier in later versions of PowerShell, but a lot of defenders probably aren't looking for stuff like this. This execution context is an automatic variable in PowerShell and is like stupid powerful. It's really, really awesome, so I definitely recommend you start looking for that. In addition, all the stuff we just did with git command, we're acting on the full commandlet name. If the object we want to deal with has an alias, then we can use git alias or its alias of gal, or alias's alias, which is called alias because, you know, the whole git dash prevent thing. So we can use that in almost the exact same way. So we'll just go with that option right there, the GCM asterisk WO asterisk. So there's a lot of options here. Maybe we want to try to look for a new object and git command and git alias and all these sorts of things, right? Well, they're commandlets, so we can put tick marks in front of them. We can also come back to our good friends, the dot and ampersand invocation operators. And again, as we can then treat new object as a string and concatenate it, or in this second example, we can actually use the -f format operator and substring and then reorder that, which is really, really powerful because some defenders have come to me before and said, well, okay, like, I don't care about your concatenations because whenever I take in command line arguments or script block logs, I remove all special characters. So all the quotes are removed, the pluses are removed, and new object magically comes back together. Well, when you start doing reordering stuff like this, it never comes back together. So let's either regex all the things or give up. So I'm going to be a realist here and just give up on new object as a solid indicator. So we're left with invoke expression. Now, on the command line, invoke expression in IEX is a really freaking good indicator. And if you're not looking for this, you absolutely should be, because there's a lot of evil out there that uses this all the time. However, as a defender, we can't become complacent just with invoke expression or IEX. There's a lot of things to keep in mind here. For example, invoke expression has the alias IEX. Order doesn't matter. You can invoke expression and then have your expression, or you can have your expression and pipe it in to invoke expression. You can also put tick marks because it's a commandlet. You can use the invocation operators and have IEX or invoke expression and do string manipulation there. And a fun fact, actually, as part of this research, we'll talk about this in just a few slides, we developed a PowerShell corpus, quite a large corpus. We'll get into the numbers in a moment, but only 3% of scripts in the wild in this corpus actually use invoke expression in the script. So kind of some interesting numbers there. It's a bit of a rarity. Then we also have invoke expression's cousin, as I like to call it, which is invoke command. Now, typically you'll see invoke command when you're running like PowerShell remoting, you want to run on another system. But if you never define computer name for a remote system, then it'll run locally. So with invoke command, you have its alias of ICM. You can use .invoke, you can use the ampersand or the .invocation operators, invoke return as is, invoke with context, so many options. And again, we have to be aware of these options as defenders. Also with PowerShell 1.0 syntax, remember that execution context automatic variable? You can also call its invoke script method there, which will receive either an expression or a script block. Because invoke expression is going to expect an expression, invoke command will expect a script block. So we can add tick marks to all of these, right, because they're commandlets. However, that ampersand and that dot, how in the world could we feasibly expect to alert on an ampersand or a dot in a command line, let's say, without getting insane false positives? Well, maybe we could say, okay, let's only alert if we see an ampersand or dot, and we also see curly braces, because curly braces are the only way that you can denote a script block. However, unfortunately, that's not true. You can actually convert an expression to a script block, and here are two ways of doing it. You can use the scriptblock.net class and use the create method, or you can use this PowerShell 1.0 execution context and use the new script block commandlet, and in fact, or the script block method. And in fact, for both of these examples, you can obfuscate them just like we've been doing all along. So there is no silver bullet. Every component can be obfuscated even further. And on the note of these invocation syntaxes, in Invoke Cradlecrafter, which I just released a couple months ago, there's actually...
Thanks, Daniel.
Yeah, I have to argue with some people. They say, how are you still a blue teamer? I feel like you have some personality disorder going on there, but I like to be thorough in my research. So in Invoke Cradlecrafter, there's actually over 10 different invocation options using this get alias, get command. So basically, it's a really interesting tool to go around and to play around with to see all the different kinds of combinations that can come out there.
That was brutal. I don't know about you, but my brain is hurting. I'm about as much as I can go when it comes to this kind of stuff. So just breathe, relax. All right.
So fortunately, the good news is that's really the extent of the obfuscation that you can perform for PowerShell. I think you guys stole the punchline there. It's absolutely not the end. There's way more we can do. We can actually step back after we've done all this token layer obfuscation and say, let me take this entire command and treat it as a string. And as a string, I can just, like, let's say, reverse the entire command. And on the command line, everything's in reverse. In memory, it's re-reversed. What we can also do is we can put garbage delimiters all throughout the command and then split and join on that. We can do a very similar thing with replace. Just say, yeah, all those garbage delimiters, let me just remove those before I invoke what's left. We can then chunk it up into substrings and concatenate it. Again, any kind of string manipulation, and it's game over. And that's kind of what we're doing with the method stuff, right? With download string, if we could treat it as a string object, it's game over. We can do any of these techniques, either on any individual piece of the command or the entire command. Now, wouldn't it suck if there's a tool out there that did all this stuff in an automated fashion? Like, that'd be pretty disturbing, right? Unfortunately, some guy wrote this tool called Invoke Obfuscation.
Thanks, Daniel.
That basically does just that. And so, if you'll take again, this is the sample command that we just obfuscated manually, right? A download Cradle with that totally legit Bitly link. And in the Invoke Obfuscation, you can just say, yeah, instead of having to go to the string token, the member token, just say, yeah, all the tokens, like randomize all that stuff, and produce something like that. You can then take something like that and say, hey, let me do some of that fancy string manipulation that we just talked about. You'll get something like that. Now, fun fact, writing this tool was very frustrating at times because debugging obfuscated code is like the worst possible wish you could ever wish upon somebody. But then
your bed, you lay in it.
But then actually when you see like APT groups using your code and you have to go and like decode it, you kind of get some dirty looks in the office, like, all right, I'll decode this one. So APT32 is a Vietnamese group, also known as Ocean Lotus, and they happen to like this combination. Typically, they'll have their payloads and they'll run it through token layer obfuscation, and then like 5 or 6 layers of string obfuscation. So keeps it interesting. So that's Invoke obfuscation. Invoke Cradlecrafter actually will take a very different spin on this. So Invoke Cradlecrafter, you can basically hand it this URL, your bit.ly link, and then it will perform completely different kind of obfuscation against this. It will do substitution obfuscation. So now, let's look like for a member, right, for download string, it'll never put that in quotes. It'll never add tick marks. What it'll actually do is it will enumerate other objects and basically say, all right, like the 37th item when I call this command happens to be the string download string, so now this big blob of text is going to resolve to download string in memory, but not on the command line. So that's where you get commands like this. So, as part of today's talk, a few hours ago, I actually released 2 new encoding schemes for Invoke obfuscation, just to drive home the point, if anyone's not convinced, that, that there needs to be a different approach when it comes to detecting obfuscation. This is 100% special characters. Now, I cannot take credit for this. There's a Japanese researcher that in 2010 came up with this. Their Twitter handle is Muraguchi, and they actually wrote Hello World 100% with special characters. And I would love to meet this person because it's a brilliant idea. It's these 3 parts they do to come up with this, but really fascinating. Now, this is basically a ton of variables, and the variable names happen to also be special characters. But you could also make those variable names just be different amounts of white space. Look like that. Now, I was having a conversation with Casey Smith, or Sub-T, several months ago, and he saw this. He said, oh, that reminds me of white space encoding. And I said, say what? And he said, you know, like white space and tab encoding. I was like, you got to talk to me about this. And so that's the second one I released today, which is white space and tab encoding. So this isn't a typo. That there's a tiny little tick mark at the beginning, and then the rest of that is either white space delimited by tabs or tabs delimited by white space, and that stub at the end basically decodes that. So as a defender, we may start to feel like really isn't much hope. So God, I'm starting to feel guilty because I feel like, you know, I'm kind of betraying my own people. So is there anything that we can do to make this better for us?
I don't know. Well, we're not even halfway through this talk, so I think the answer might be yes. I think we could do some smart stuff here. The big thing to realize, so hold back, we're not professional data scientists or anything. We're going to do some journeyman science here. The big thing when you take a look at this, nobody looking at either of these scripts is going to be like, that's fine, let's just let that through. You look at this thing and you got a spotlight. We've got an opportunity here to take what attackers are using as this subversive cloak of invisibility and turn it into this laser of like, look at me, I'm in. So what are the ways we can do this? Is start thinking about character frequency. Like you look at this and you say, that's a lot of ticks, that's a lot of braces. So character frequency, let's do this. We did some analysis against Poshcode, which is a popular PowerShell script sharing repository. So on the right there, you see that's what, when you take all the scripts in Poshcode, that's what their character frequency looks like. You know, you've got some pretty regular English characters and stuff. On the left, there's 2 examples of what those obfuscated scripts look like. They look nothing like what a regular PowerShell script does. And at this point now we have sort of vectors of numbers that we can start to actually apply some traditional techniques. Now, one thing that's out there in the information retrieval community is called cosine similarity. The idea there, search engines use this a lot. They characterize a document based on a big old list of numbers. They call them features, but they're numbers. Big old list of numbers, and then you compare all these numbers together, and then you try to look for ones that are very similar based on this math here. So when you're doing cosine just on little graph paper, grade 10 or whatever, a line on paper is represented by 2 numbers. That's a 2-dimensional line. You take 2 lines, that's another 2 numbers. And then you can take the cosine of that and figure out how similar the lines are by basically how much the angle between them. So you could take this exact same approach and extend it into 3 dimensions or 4 dimensions, and you could do a lot of dimensions and put a nice looking math symbol there and feel like you're so happy. The truth is, these don't need to be dimensions on a graph. These can also be just other numbers, like character frequencies. When we take that cosine similarity and start to apply that on character frequencies across all of Posh code, this is an example. So most of the scripts, they show up as being like 0.97 similar to an average PowerShell script. These obfuscated ones, they stick out like a sore thumb. We've got 0.15 similarity. We've got 0.37 similarity. This is what it looks like when you take those similarity metrics to the average PowerShell script across all of Posh code. We see just a really, really great grouping here above about 0.8. Anything below that, when you took a look at, you're talking about reducing 3,500 scripts down to like a couple dozen. When you do look at these, most of these things below 0.8 actually do have a lot of characteristics of obfuscation. And when they weren't done intentionally, a lot of times they were done as part of some sort of code golf competition or something like that. So, it makes sense. So it's really good metric of a way using cosine similarity to start really, really finding some high density obfuscated stuff in your environment using log processing.
So at this point, we were pretty happy with these initial results, but wondered, this is really just Posh code. Like, there's other PowerShell scripts out there that we could get our hands on. So Microsoft last spring ran a little contest called Underhanded PowerShell. And basically, it's kind of a 2-phase contest. And the first part was more of the red team phase. And basically invited the community to submit underhanded or obfuscated or obtuse PowerShell code to perform a specific task that got around certain script analyzer rules looking for this certain activity to happen. So that was one part of this. And then we really said, we need that was a few hundred scripts that were really, really fascinating. But we said we need more. We need more data. So what we decided to do was to build a PowerShell corpus. Now, however, we're both gentlemen, and so we did this politely. And what I mean by that is that Lee wrote this nice little script to scrape GitHub, and those blue portions are the portions that are scraping GitHub, and the red portions are Canadian. Because Lee is Canadian and is so polite. So it's like throttling, it's just so generous. So it's really, really a gentleman in how he scrapes the internets.
But mad props to GitHub. So we had this thing running for literally a month. We took a look at all the GitHub IDs, and I'm like, okay, 10 million GitHub repositories, start scraping through those. A month of doing this. And then it gets to like 11 million, 12 million. I'm like, time's ticking. Looked it up again. It was actually 100 million repos. And so I didn't feel like waiting for a year to have this finish. Reached out to the GitHub folks, and they ran a little back-end query, gave me a zip, and it was all good. So.
So the most polite thing is actually just to ask the people you want the data from. So big thanks to GitHub for that. And so we'd like to thank all of the contributors. We'll have time at the end to get to that, but there's a lot of contributors out there. So if you wouldn't mind raising your hand if you've ever submitted a PowerShell script to GitHub, TechNet, Posh Code, PowerShell Gallery. Has anyone ever submitted? Awesome. Thank you so much, because this research wouldn't be possible without you. So your name is actually on that slide, and it is packed in the code in some fun places, which we'll get to at the end. So really excited about that. So now, once we got all these scripts, we had the realization that, oh my gosh, we actually have to look at these scripts. So there's some interesting things you might find when you gather this kind of corpus produced by human beings at a keyboard. And some of the stuff was just really sad. We found this. It was called removegames.ps1. The author, oh crap, Matt Graber. Yeah, okay. So this guy, I don't know if that's right, but basically this removegames.ps1 will go through and find the default games, kill those processes, and then at the end actually remove the freaking directories. So I haven't investigated where the high scores are stored, but if it's lost in this, then that makes me pretty sad. So major buzzkill. But in all seriousness, we actually found some heavier stuff.
This is brutal, absolutely brutal.
It actually kind of paused our research for a little bit to figure out how to handle this appropriately, but we actually found a plot to kind of overthrow a really interesting set of people at a certain nation state. And that was this script: to let's fill the logs of the US House and Senate servers with a message that we don't want SOPA. So the Stop Online Piracy Act. So a lot of interesting stuff there. So going back to the serious stuff, again, we needed more data. So the PowerShell corpus that we assembled and that we are actually releasing as part of this research came up to 408,000 PowerShell scripts, contributed by at least 28,000 authors. We actually identified about 1,600 obfuscated scripts in that data set. And then we produced around 4,000 obfuscated scripts by randomly taking these PowerShell scripts and running them through Invoke Obfuscation, Invoke Cradlecrafter, and then PowerShell ISE steroids obfuscation. And the interesting thing to note here is in the middle on the right, where we manually labeled 7,000 scripts. Now that sounds really tedious. Why would we do that?
I don't know. One of the things that's amazing too is that this is 4 gigs of text. If you type that by hand as fast as you possibly could, the average person types 50 words a minute, did that 8 hours a day, like 365, you're talking 30 years of nonstop typing to make this corpus. Like, the amount of humanity represented by this is crazy. But 7,000 scripts, why do you actually, everyone thinks hacking is pretty awesome, like you're in a hood and you do crazy music and stuff. It's kind of boring. You sit there, a notepad window pops up, you take a look, it's good, close it, label it. So there's some PowerShell scripts to help out a bit, but this is why. We talked about how happy we were with that string similarity metrics, right? Where we were able to say, all this stuff below 0.8, that stuff looked pretty sketchy, and we're happy with that. What we didn't point out, though, we didn't review the stuff above 0.8. Ryan Cobb did some interesting investigation kind of going along that path, and the real measure that you need to focus on, and he did find that if you change that 0.8 to 0.7 or 0.9, it starts to get a lot less good as a metric. So when you're trying to be a bit more kind of principled about this thing, the way that you traditionally measure things is by the 2 main things are precision and recall. So precision says when this thing had an answer, how often was it correct? So basically that's the measure of false positives. And recall says of all the bad stuff that's out there, all the obfuscated stuff, how much did it actually give you back to take a look at? So this is an example here where precision was pretty good, right? It was right almost 90% of the time, but recall, that was not a happy time, 37%. It was really not returning that much of the obfuscated stuff. There was a ton of stuff above that 0.8 that when reviewed manually or visually was considered obfuscated. And the F1 score is a thing that people use to kind of combine those 2 things. And that's where you see we really have some problems here at 0.52. So there's clearly some dangers of character-only stuff, but not only the problem of looking at characters, but if you just look at characters, there's a big opportunity for attackers to start manipulating those character frequencies. So this is PowerShell, one of the most powerful things ever invented. I love it. I have its babies. We've got the power. We could do a lot better than just simple character frequency analysis.
Yeah, so how might we get more data points other than just character frequency? Well, PowerShell, when it sees code, it knows its own, and it has to have a way to parse that code. And what we're looking at here is actually PowerShell Abstract Syntax Tree, or AST. So when PowerShell sees this command at the bottom, it says, okay, get command, that's called generic. It understands these left parentheses and right parentheses. It sees that the -f is actually a format operator. We also see these strings. And so the neat part about this is that PowerShell doesn't only recognize what these items are, it also recognizes how they are related to every other piece of the command, thus the abstract syntax tree. So what this means is that we can actually go really deep and inspect the script in a really deep fashion, not just looking at it as a whole and looking at characters. There's a great little GUI out there for viewing PowerShell AST called AST Explorer out there on GitHub. So a really cool tool just to use to kind of type in a command and see how does this actually break out into AST.
And this is ridiculous. Like, you just open up a PowerShell window, install a module, show PSAST, you get it, you run it. Like, PowerShell makes it so easy to get useful stuff onto your systems.
Exactly. And so now, what we did with this is we said, okay, instead of just looking at character frequency for the whole script, how many features can we possibly get? So we started with AST types. So basically, in this entire script, how many commands do we have? How many parentheses? How many operators? How many members? How many strings? All this stuff, just getting counts and percentages of the entire script. What percentage was this? We did the same thing with operators, so assignment operators, binary operators, unary, invocation operators, array size ranges. An array of 5 elements is a little bit, it could be interesting, but one of 5,000 elements, that becomes interesting. Maybe that's shell code. So we got that data. And then for every single one of these, we ran character frequency analysis on each of those elements. So just on the strings, just on the commandlets. And we didn't just do frequency, we did frequency, entropy, we did the length, max, min, medium, mode, range, average. We did white space density, character casing, a lot of fun stuff. And we also did statistics on the command names, .NET methods, variables, etc. And so what that resulted in was a lot of features. Actually,
Yes.
4,998 features. That's crazy. And then we realized, oh my gosh, what do we do with all these features?
Here's a thing. There's a technique that is really common in statistics called a linear regression. So you could do this in Excel. There's a lot of plugins to do a linear regression. So the way that a linear regression works, so we talk about features, right? Those 5,000 features. So you might talk about, well, how do you figure out which ones are the most important or not? So for each feature, you give it a weight. That's just a way to figure out the importance. So I take the combination of weights and their features, do some multiplication, add it up across the whole 5,000, and if it's over a certain level, like if that number, whatever it is over a certain number, then maybe you call that obfuscated. And if it's below a number, well, then it's not obfuscated. Now the thing is, the numbers coming back from these features can be kind of rangy, like way up and down, way up and down. So you had this other thing called a logit function that basically takes all your features and scales it down between 0 and 1, just so that you don't have one thing where like somebody dumps in a script with 14 megabytes in a character array that just totally trashes everything. So this is a way to kind of squish those ranges a little bit. So you combine the linear regression with a logit function, and that's called a logistic regression. So that's a pretty common thing as well. So again, another graphic of math to show how smart we are. You basically take those features, send them through this logit function, and you do the same thing. So now you're doing a linear regression on these logic functions. Then there's the other big question, though, you have is like, what do you do? Like, that sounded smart, but you still didn't answer the main question, is like, how do I figure out all these weights? That's an art, that's a science. Do I like phone up Debo and be like, hey, Debo, is like a character array like a bad thing? And he's like, I don't know, like, how many false positives are you going to get? How many false negatives are you going to get? So the trick there is another statistical technique called a gradient descent. Now this exactly is why we went through all the painstaking effort to label tons and tons and tons of data. Because what you do need is a source of truth. So this gradient descent says, I take all of these weights, and I just pretend that they don't matter at all. And then you go through this data set of stuff that you know, that you've labeled, and then you get an answer. You say, I'm going to run my calculation. I think that it's obfuscated or not based on these numbers. But then you have an actual answer of, like, are you correct or not? So if you're not correct, there's always going to be some error between what you thought it was and what the actual value is. You can take that error and feed it back and then adjust all those weights based on that error. So the big weights are going to get adjusted the most when they're wrong, and the small weights will get adjusted the least when things are wrong. So this is the approach here. You run this gradient descent on all these features, and you get a really big weight vector that you can then go off and apply to any script and decide whether it's obfuscated or not. So does it work? I think so. Take a look at this. we got 94% of obfuscated in the wild PowerShell scripts with only 1% false positives. That's something you want on your team, absolutely. So this thing became 10 times better at finding the bad than character frequency analysis alone with half the false positives. But that was stuff in the wild. Some people in the wild are just like, woo, YOLO, just dump everything at it. What about just sketchy stuff? You're in the midst of an incident response, or you're trying to take a look at something, and you want to cast a much wider net. You want to say, that one on the left, that's like to the wall, obfuscated. The one on the right, like, I don't know, maybe it's obfuscated, maybe it's just sketchy. Like, it doesn't look like a regular PowerShell script. Maybe I want to have, if I had the best intern ever, them to say, hey, Lee, like, take a look at this. I don't know what it does, but I think you might want to take another look. So what we did is we ran this again with that as a bar of what's considered obfuscated. So really looking for a deep analysis of script blocks. Still, like, really, really epic. When you start talking about the deep analysis, you're still getting 88% recall. So 88% of all stuff that anybody might consider kind of sketchy or noteworthy is coming up. And you still only have 5% false positives. You're catching a wider net, casting a wider net. And the most important thing, too, here is that when you start talking about in the wild stuff, what we had there of the 94% in the wild being caught, when you're casting this wider net, that now becomes 97% of in the wild PowerShell scripts being able to be caught by this algorithm. So, you know, logistic, all that kind of stuff, logistic regression, are there any other ways to do this? And there are. So what we did is, as part of this, we generated a huge CSV of all this stuff. And you can dump this into a place like Azure Machine Learning Studio and see what it looks like when you're doing the logistic regression. There's other ones. There's one support vector machine, and there's boosted decision trees. There's a bunch of different ways that people are applying statistics at scale to do basically categorization of data. The closest one was the boosted decision tree. With this research, we ended up getting about the same answer as the logistic regression in a kind of a professional machine learning studio. The boosted decision tree got us pretty close as well. It was a little bit worse, and then the other two were much worse. So this is pretty awesome stuff.
Would anyone care to see it? All right. So if anyone knows me, I'm obsessed with the right host commandlet with colors. So I couldn't refrain. I had to put some ASCII art out there. So this is what you get. Basically, a script, analyzing it piece by piece, throwing some of the actual statistics that we get out of it. Some number of features, how fast it takes, on average, less than 300 milliseconds to analyze any script or command with this tool. To be honest, this entire function actually serves no purpose in finding evil. It's simply for the lulz and for the colors. So if you don't like any of that stuff, just don't run Revoke Obfuscation, and we'll show you the more important functions later. But if you do, there's a tutorial. It's also known as the README, but this one has colors, so you can look at that. Fun facts. There's a lot of interesting statistics and fun things that we found in this research. Some more goodies in the corpus. So just run fun facts and see what comes up there if you're feeling down on yourself that day. Also, when you collect almost 500,000 PowerShell scripts, you're bound to find other people who do some pretty interesting ASCII art. So you can check out some random ASCII art there that we found in the corpus. It's quite nice, and it'll show you a URL to the project if you want to check it out. A set of fun quotes, and then credits at the end. Again, if you'd like to see maybe your name pop up there, then we have all the contributors sitting in there. So good times. And actually, we had a nice little subsection of our favorites that have some pretty fun names. But if you're actually looking to, find evil and not just laugh, then there's two things you want to know. One is get RVO script block. Now, what this is doing is we tell people, okay, upgrade to PowerShell 5, enable script block logging. That produces a lot of data, though. And a lot of times, that entire script will be cast over several different event logs. So what this will do is it'll go through and group and reassemble those into PowerShell objects. So if all you have is a get when event across a lot of systems, or if you just have the raw EVTX files, you can pipe it into get RVO script block, and it will reassemble those scripts for you. And now, once you have either a directory of scripts, or you've reassembled them from script block logs, how do you actually find evil? It's simple. All you do is pipe it into measure RVO obfuscation. And there we go. So now RVO is the short name for revoke obfuscation. But as you can see here, it's really colorful. It's kind of like Christmas, red and green. And in the results you get back, you have the script content. You have is it obfuscated. You have all of the script features at the bottom there. You have the time it took to pull those features, the time it took to measure those features, everything. And lastly, our desire was always for this to be usable by anybody. This isn't just some research tool that researchers can have fun with. We want this to be practical like today, as in like we just pushed it an hour ago and it's live on GitHub. We want you to be able to take it home and use it right out of the box. And so from an operational perspective, we really wanted to make it as easy as possible to whitelist things that you've looked at that this has said, hey, this seems obfuscated. And you can say, all right, let me check it out. Okay, this is fine, this is not obfuscated. You can just drag that into a whitelist directory and it'll hash it and basically whitelist that anytime it sees it again. You can use content or regex, and again, all of this is in the tutorial, all of this is in the README. But again, our hope was that we could make it as easy and usable as possible for anyone in any organization.
I remember when I was showing how easy it was to install the AST module, just as easy. You get home, install module, revoke obfuscation. This is up on the PowerShell gallery as well. You get this on your system immediately. You can start detecting obfuscation in PowerShell scripts in like 30 seconds.
Exactly. So as we said, this code is live. It hosted on my GitHub and also the PowerShell gallery. So again, just install -module, revoke -obfuscation, and you have it on your system to use. And just a couple references. This initial blog post from Lee Holmes last fall was kind of what started my interest in this and kind of formed this little team up here looking at this. And then he actually had a couple blog posts on that, and then some MSDN resources. And the last blog, if you haven't read PowerShell Hearts the Blue Team, it's a phenomenal blog and white paper about all the stuff the PowerShell team has built into PowerShell for security people, for security purposes, and it's really, really great. Thank you very much. That is the end of our presentation.
Thank you.
Do we have any brave souls for questions? And if you have a question, if you wouldn't mind heading up to the microphone, and we'll be around afterwards also if you don't want to speak into the microphone. But any questions?
I'll ask one. So I was looking at your character frequency analysis, and it looks like it conforms basically to Zipf's law. Did you look at any of the power law stuff for distribution of characters?
Yeah, the distribution of characters there, bigraph analysis is another common thing to look for commonality of like 1-2 punches, like A, E, T, I, that kind of stuff. You end up running into some of the same issues. At the first order, the Zipf's law stuff ends up showing at the regular character frequency as well. It's definitely interesting. We ended up packing that intelligence into the entropy measurements, because that also shows it as well. So we're doing entropy on everything: command names, variable names, function names, method names, everything. But good question. Thanks.
Thank you. Any others?
I got a question.
Yeah.
Have you found any legitimate uses of obfuscation in scripts that weren't malware? Like how much of that was going on?
The primary kind we saw were people trying to use it for IP prevention. One of the tools that we used was one from ISE Steroids, where he didn't write it as a malware vehicle, even though malware has used it. He wrote it as somebody wants to protect their intellectual property, obfuscate it so that it becomes a little bit harder. That's really the primary place we've seen it elsewhere.
Cool. Thanks.
Thank you.
All right, thank you. Thank you for staying so late. Oh, one more. Sorry.
So if I understand correctly, it's actually first time run the code and it checks in the evaluated code. So for instance, if I would add a large a large, a lot of code to my obfuscated script, and if I would, for instance, place it in an if block that would never become true, would that throw off your system? So for instance, I have like 10 lines of obfuscated code, and then I take 1,000 lines of legitimate code, but I placed in an if block that never evaluates true. Would your system then see it as a legitimate script?
It might. That's one of the big questions. When we did the analysis of the 7,000 scripts, we did for sure, there's a lot of things that are like line by line as opposed to the entire script itself. So we did do a lot of investigation of like, hey, this one little chunk is like a huge confusing thing. We're going to call this obfuscated. And the kind of the funny thing about the gradient descent and all that is we don't actually know exactly what it calls as the important stuff. But the really critical part is if that actually starts becoming a thing that people do, well, then you just start feeding that back into the corpus, labeling it correctly, and rerunning your learning on it, and then you can start to pick up those things.
Okay, thank you.
Thanks.
Yes.
So the question is, I was a developer on PowerShell. Why the hell did we put all this backticks and escapes and all that? Is that the question? Because they are used very, very, very frequently for non-crazy things. The truth is, when you have any sort of engine that can do computation, you can do ridiculous stuff with it. If you've ever seen one of the brain F*** competitions, there's like literally 4 characters you can use, and it's messed up. So, you're never going to get a language that cannot be used in this manner. What we have done in PowerShell is go like crazy on making it transparent when this happens. So when you enable script block logging, PowerShell logs all this stuff to the event log. All that stuff you saw with the shield gets unraveled automatically when it gets to the event log. We've also done things like anytime one of these things is interpreted by PowerShell, it can also ask antivirus in line whether this is okay to run. So not just stuff off the disk, but you go through 3 layers of eval. All those things are being sent into your event logs and the anti-malware. So with great power comes great responsibility, and I think we've done it both ways. Thanks.
Well, thank you very much. I know our time's up, but we'll be just outside in the room. We'd love to chat and hear your questions. So thank you again very much.